Hi, I'm Raj Sodhi. I'm an engineer here at Keysight Technologies. One of the biggest challenges our electronic warfare customers face when designing systems is characterizing unknown radar signals. Today, I will describe a new measurement solution that enables the data capture of long-time records of signals from the electronic battlefield. Let me show you an example. This is a dense radar environment. The surveillance aircraft is being hit with numerous radar emitters. We do not know the transmission frequencies, radar modes, or transmission times. To prepare any kind of countermeasures, our EW engineer must measure and analyze enemy radar signals to mitigate their effects. Here's another problem. The red force radar will spontaneously change modes to avoid detection, or when it switches from a search mode to a tracking mode. What if we could observe a real RF environment and collect all radiated signals so that the emitter characteristics can be clearly understood and even played back? Our real-time streaming turnkey solution makes it easy for you to collect hours of IQ signatures at bandwidths up to 255 MHz and 78 dB of spur-free dynamic range. It consists of a Keysight UXA X-series signal analyzer with real-time IQ data streaming option and an IQ recorder from one of Keysight's solution partners, X-COM Systems. Okay, here's my measurement setup. The UXG is used to create an agile signal up at 10 gigahertz. It's meant to be as realistic of an emulator of the electronic battlefield as possible. That is then fed to the UXA signal analyzer, which acts as a very high performance down converter. The down converted IQ pairs are streamed out the back of this UXA and fed into the X-COM recorder, which then stores the data into a RAID array very efficiently. Now let me show you the process of making a recording. We can record the IQ data pairs by simply typing in a file name and then hitting the record button. The scroll bar is indicating the progress. This leads to a very large file, in this case 6 gigabytes. We then offload the data using a PCIe Gen 2 interface. It's transferring at 550 megabytes per second, although it slows down as the disk drive fills up. We now have our waveform opened up in SpectroX. We can see the full 5 seconds of recorded waveform. Here in the middle, you see a sudden change of shape to the waveform. It turns out that between 2 and 3 seconds, we were painted by another emitter. This is our emitter of interest. We can zoom in on the emitter of interest and look at its properties to see what happened here. This appears to be a scan modulated emitter. Let's take one of the bigger lobes and just look at that. Redocking this overview, we can then play what's happening on this waveform during that moment in time. This shows the time domain plot showing the individual pulses. But suppose we wanted to get a catalog of the parameters. We can run a pulse search. For any particular pulse, we can verify the PRI and the pulse width, and even get a spectrogram and the magnitude in the time domain. Zooming into our spectrogram, we can isolate the interferer of interest, and we can even export a section of this waveform to the Keysight VSA software, or you can also bring it into MATLAB. Here I draw a rectangle around the section of waveform of interest, and now you can see the time range has already been set for me. Go ahead and start my export. And now that's done. I'm going to recall that same file in the VSA software. Here we have the slice of our waveform brought into the VSA software package. We can see the spectrum, the time domain waveform, the phase changing across pulses, and here we have a pulse table that shows all the relevant parameters for each of these pulses that it has identified. We may also export the data to MATLAB. We read it in by calling the file name, and we will get the complex IQ data, and then we can plot that. Signal characterization of unidentified radars is simple with Keysight's UXA signal analyzer equipped with option RTS for real-time wideband IQ data streaming combined with X-COM's recorder. This integrated solution allows you to continuously record large amounts of data over 255 megahertz of bandwidth and rapidly isolate specific portions for detailed analysis with DSP tools from Keysight, X-COM, and MathWorks. To learn more about how to accelerate your characterization efforts, please talk with your local Keysight field engineer. Thanks so much for watching.